Welcome everyone to yet another iteration of talks that we have here at Humans VV. We take your questions and bring to you the unique takes on them by the doyens of the EV industry. Today we have with us Dr. Ramesh Singh, who is the associate professor at KIET and is actively involved in research, where he is also delivering his services as the in-charge coordinator at Center of Excellence for Electric Mobility at KIET Group of Institutions, where he is responsible for the analysis and design of different topologies of motors and development of advanced BMS for more efficient and cost-effective electric vehicles. It apparently is a long flurry of credentials for Dr. Ramesh. He received his Bachelor of Engineering degree from REC Hamirpur in 1999. He also earned a Master of Technology degree from NIT Jamshedpur in 2006. Subsequently, he went on to earn a PhD degree from Delhi Technological University in 2020. Dr. Ramesh holds one international patent and 3 Indian patents under his name. He has published 7 papers in reputed international journals and 8 international conferences. He is an active senior member of IEEE USA and serving as ambassador of IEEE Smart Cities USA in India. Hello, sir. Please accept a warm welcome from me and Humans of EV.
Good afternoon. It's a pleasure for me to be a part of TelioEV and represent Kite Group of Institutions as a Center of Excellence for Center of Excellence E-Mobility.
Thank you so much, sir. We are just ecstatic to have you here and keenly look forward to this conversation.
Sure. Same here, sir.
I have some questions to which we would love to have your answer and share the unique perspective that you have being so close to the revolution that is happening in e-mobility. So first up, we would like to know more about your work in the analysis and design of motors and battery management systems.
See, motors and batteries are a kind of thing which are the basic prerequisites, or you can say a very basic thing, a learning tool for any electrical engineer. So the moment I passed out or got my engineering degree, later on MTech and PhD, I was more or less focused about these motors and the energy management solutions. So there are many kind of motors which are presently available, or they are from the very past. They are used across for all the industries and household commodities. But when you are specifically talking about electric vehicles, the present domain, it is dealing maximum with the permanent magnet kind of machines. So my focus was something which was cost effective and nearly achievable for Atmanirbhar kind of Bharat, that is for self-development. Since BLDC is a kind of solution, or the permanent magnet in whole, that I will say, are a kind of solutions for which we have to depend upon some other kind of sources or countries. Let it be like China or Korea, something like that. So our main focus over Center of Excellence over here are not only to concentrate on permanent magnets, but also some kind of other feasible solutions which are readily available in India. So whenever we are going for such kind of analysis, or we are going such kind of replacement or comparison, technical kind of comparison, we should from very first thing that we should be starting from is the mathematical modeling of any kind of machine. So what we choose an induction motor. And since induction motors are also of various types, like single phase that is readily available in our households in the form of ceiling fans, and 3-phase induction motors which are available in our industries, we try to focus on some other kind of solutions from induction motors, which are having higher torque speed characteristics and effectiveness in the terms of controllability. So the first step was to make a mathematical model of the conventional 3-phase induction motor and a 6-phase induction motor. Now, the 6-phase induction motor that we have taken up is an asymmetrical kind of dual induction motor, and a mathematical modeling was done. And later on, the different parts like inrush current, torque speed characteristics, controllability, all these were formulated. Now, the results were very much improving, and they were very much encouraging. So we later on went for a MATLAB software solution, and where we modeled the 6-phase asymmetrical induction motor in a simulating kind of environment. There we had subjected this kind of motor in various kind of roles, like from no load to full torque and double of the loading speed characteristics. And the results were really very much fantastic. So what we achieved from the simulation results was that when we compared them with the conventional 3-phase induction motor, the the torque speed or the torque, if you say the driving force,
Yeah.
is approximately 2.7 times of the rated capacity of a three-phase induction motor. Then taking these kind of capabilities, we later on went for the also finite element kind of analysis, because in MATLAB we can have a kind of overall steady state or some kind of transient kind of phenomena. We cannot have a flux hotspot or these kind of analysis. So we went for a finite element analysis software called MotorSolve, and using that software we analyzed this whole machine, and side by side we had a comparison with three-phase induction motor, permanent magnets, both machines, BLDC and PMSM of the same rating we took. The rating that we took was 5 kilowatt machine. We took this machine rating because we could have easily fabricated or we could have easily wounded in our lab also, and which we later did also. So the finite element analysis was also very much positive for our side, and we all saw in our lab that the multi-phase induction machine is proving to be best. Now, the next only thing which was left to fulfill all the dreams was to make a hardware kind of model. Then we made a hardware kind of model and for a 5 kilowatt induction motor. Now, since this is a typical kind of machine, so all the rotor frames, stator frames, and all those things are not there presently in market in India. They are obviously in some other countries like USA, Massachusetts, it is available, and some other top labs that are dealing with these kind of things, they have availability of these kind of things. So what we did, we took a three-phase convention motor, we took and rewounded it for a six-phase asymmetrical dual induction motor. And we did all the kind of parameters like fault, low voltage, high torque, no load, full torque, full speed, all kind of characteristics we did. The test that we had performed in the mathematical, finite element, and MATLAB. The hardware results were totally promising and they were totally mixing with all these kind of things. And finally, we are at a date right now at a stage where we can say that asymmetrical dual kind of induction motors are really a real substitute and a cost-effective solution for EV of India, where we are trying to go for Atmanirbhar kind of situation. Because for this, we do not need a permanent kind of magnets which are available in other countries. The skill of India for winding and all those things is readily available because induction motor market is already saturated and a top many people are there working in this field. So later on, the development for this hardware model for six-phase induction motor was compared with the hardware models of three-phase induction motor, which is usually called as SCIG, SCIM, and BLDC, and permanent magnet. So we had a hardware setup for all these kind of machines, and we compared the same results, and we exported all these methods on those machines also. The results were good, but not to that part as what the three-phase induction motor. And when we compared the three-phase induction motor with our six-phase induction motor, the results were astonishing. So the result and the conclusion that we achieved was if a EV industry is adopting for a six-phase induction motor, which is asymmetrically wounded with some of the basic skew and design parameters, the results are very good. Now, the results that we had basically taken were the top speed characteristics, which is a very common kind of issue for a EV industry, and the various kind of torque propulsions. Because if you are driving a fan, slight kind of vibrations may do, but when you are driving an EV or you are on a road, there should not be any kind of vibrations. So these torque propulsions were least in all these machines in asymmetrical dual kind of induction motors. Moreover, since the machine was running on six phases, the reliability was quite high because it was now dealing with the six wires and six phases. Now, since whole power was routed by the six phases, the current per phase has also reduced. So this resulted in the loss of uh, heavy kind of magnetic circuits and smaller magnetic circuits were being used, which again resulted in less cost. Now, since current was very less, current was approximately half in each kind of phase. So we had gone for power electronic solutions, and the power electronic converters for less current, everyone knows, are at a very cheaper cost. The larger the magnitude of current, their cost increases very high. So overall, the ease of control and the degree of freedom for all these six phase was very nice. So this is what we had exported and exerted in our lab. And though we have a setup for permanent magnets also, and three-phase machines also. But we are readily available for these kind of solutions to the industry. Six-phase induction motors.
So certainly the six-phase motors appear to be having some serious implications as far as the performance is concerned. So do you think, or would you like to comment of any implications that they have or may have on the energy efficiency of the particular EV vehicle where they are being employed?
Yeah, since we are talking of EV, so the driving force is electrical. And a very common formula that everyone knows is the power loss is given by I square RT. So I square R, and depending upon the time domain, it is with the energy loss I square RT. The efficiency is also dependent upon the current. Now,
Correct.
as I have mentioned earlier, that the current has reduced to half, the square of that value has very less magnitude. So
Okay.
efficiency of these kind of machines is also very high. So efficiency-wise, these machines also worked very well. When we compared with the BLDC and the PMSM kind of solutions, these machines draw heavy current and the constant current is there. So there was a loss of efficiency in these kind of motors when we are comparing with ASIG kind of machines.
Okay. So
Yes, Anand.
apparently it's an all-round greatly capable solution that you have come up with, and I hope so. What are you, how are you looking to move ahead with it, if I may? Are you looking, or is this something in the prototype stage, or have you moved well past it and are looking to commercialize it? How exactly are you looking to move ahead with it?
Basically, right now we have developed a prototype and it has passed all our tests. Now we are going for some kind of industry collaboration. We are searching for that so that these kind of motors maybe fit any kind of EV, and later on scope for self-made Indian-made EV is totally there, because EVs are right now made in India, but the parts are basically brought from different countries. So it is just some, or you can say roughly, it is assembling in India somewhat kind of thing. So if it is an induction motor, it will be totally made in India kind of concept. The only limitation in that will be a battery kind of concept, the energy storage, which is a very huge kind of R&D market and explosion is there. Many battery topologies and many battery conventions are there. But sooner or later, as some days back, only 5 to 7 days back only, Harvard University has developed a EV cell which can be charged in 3 minutes and it can run up to, or its life is 20 years. So usually what we had a lithium ion kind of concept, lithium ion phosphate presently in a EV industry, it takes charge of maximum which was 30 minutes, and the year that they will be lasting for 8 years. So the Harvard kind of technology that they have developed, the EV cell, is 3 minutes and 20 years. So that is also a breakthrough in this kind of, daily some of the other kind of breakthroughs are coming in the EV field and in the terms of energy storage.
Absolutely a national
And
pride
more,
as well, sir.
yeah, and moreover, apart from that, we should be also concentrating on some other kind of non-conventional kind of energy storage methods which are not readily available, such as fuel cells are there, and some other kind of like vibrations and torque propulsions are there in tires and rims and chassis. So that can be also extracted by the EV for the energy solutions for longer run.
Just I mean this may be a little plug-in, but just the other day I was looking at a video from Interstellar where the person mentioned the Indian Air Force drone. It's Indian, and he the connotation was, since it is Indian, it will be really good. So that was something for fiction, but yeah, looking at something today itself, I mean, I just watched that particular scene yesterday, and watching this today, seeing that thing to be told in reality by the world, it gives immense pride to me, and I am sure that it will give immense pride to you as well.
Yeah, surely researchers of India are basically doing top everywhere. They are going to US or they are going to China, they are going to Japan, they are bringing dollars. But the basic thing is what we have learned from India and what are the resources from India, we should be trying to get the best from here only. And if such kind of solutions are readily available, then obviously it will be a showcase for the whole world that we are self-reliant and we can sell this to the whole world.
Correct.
So obviously जो एक गुरु वाली एक बात होती है, that will be available for the whole world.
Great, make in India and cater to the world. So that
Right,
that
right.
really has a nice ring to it. Moving ahead, Thank you for the answer to this question. I am really glad for this elaborate insight. So moving on to the next question, probably this this is going to be the most popular question of the lot. That is what I assume. What are some efficient and cost effective solutions for EV industry in which direction students can work in?
See, the students can work in various domains. See, EV is a complete industry in itself. So there is a scope for electrical, mechanical, chemical, all these kind of engineering branches that are there, they are there. Moreover, the software engineers are also playing their major role. With the help of different kind of softwares like Pythons, they are doing programming. In our lab only, they have a software engineer of fourth year is there, who is doing his project on the fault prediction of induction motors. So depending upon the voltage and the current ratings, we are trying to find out if a fault is going to happen or not in the next 1 year, 6 months, or something like that. So it will be a predictive kind of maintenance. So before the machine is going for a fault, we will be able to detect it. And once the machine goes for a fault, it is a breakdown, it is a huge loss for the owner and the company also, because somewhere the resources have to be either plugged in or it should be refurbished. But before a fault has occurred, a minor kind of adjustments may be there, and it will be a cost-effective solution. So one way is the software solutions are there. Next is machines, as I already told, newer machines are there, which can be a breakthrough for the engineers and they can work upon it. Promising engineers, that is BTech engineers. So not only BTech engineers, I would like to emphasize all the graduates and postgraduates, which are basically MBA students and basically all the other kind of streams also, which are somewhat technical, like physics, MSc, chemistry. They are also doing their part. And moreover, with the help of AI, ML, and IoT, not only driving is a main thing. We are dependent upon cloud. So the availability of chargers, it can be on your mobile app, so that how far your vehicle can go. So these kind of softwares also can be developed with the interface of the core engineers branches and with the help of power electronics. The power electronics is a very important feature. The students can venture in this field also. So depending upon the various power electronic switches, like gallium nitride devices or MOSFET, they can be tuning the various circuits in an optimal manner. They can be reducing the control algorithm, so that nowadays the control algorithm is very complex. So the moment this complexity goes on less, it reduces. The cost of the R&D will also reduce. So these are the various features, like they can be working upon the degrees of freedom. They can be also working on the non-conventional kind of energy solutions. Like there is a method, there is a generation of PV, fourth generation kind of PV, where we have a like paint PV will be there. Paint sprays are there. Paint sprays will be covered all over the area where you want to do, and they are totally transparent. Some portions of anode and cathode will be taken out, and they can be used for battery charging. So if these kind of solutions are coming in EV field, you can take any EV, you can just spray all that paint on your body of that EV, and the whole body of your EV becomes a cell, solar cell. And that solar cell is generating power that is charging your battery. Right now, what maximum we can do, we have flat cells that we can take on our top of our EV, or we have some other kind of sources. So these are the various kind of ventures which the students may go upon and they should be looked upon, because technology is radically changing. What I am telling you today, tomorrow it may be plus something else. So this delta is very fast in EV field. So these are the various methods where they can work upon. The most promising thing which an EV should do is they should be working on safety features. So the safety features are very important, because right now the EVs are soundless. And we have an idea of a vehicle when it is coming from our back or side, that it will some humming sound will be there. The engine sound will come. Now, because of the no noise, many accidents are also occurring.
Yeah.
So that is also a point of work where some noise should be put. Now, there's the role of psychologist. So, which kind of sound should be used so that it doesn't make an irritation to the driver and the commuters also. So, various kind of operators. So, I told it's a complete industry. So, it's a complete industry which is incorporating all the engineers, management, psychologists, chemistry, physics, everyone. So, it is a very promising field, and all the engineers, not only from engineering field, they can do a lot in this area.
Apparently, whatever you can think in science has a very
Has
has a
its
deep relevance
application
for
in
you.
EV.
Correct, correct.
Yeah, very right.
You already, I mean, this was something that I was going to ask you, but you already answered this question. So I was going to, what I was going to ask you is, do you think of any renewable energy system, since you've been a faculty of renewable energy systems, do you think there is something that we can integrate, or there is some way where we can integrate the same technologies in the EV industry?
See, I'll just go somewhat side by side also from this question. Since EV is a booming field, and according to Nitin Gadkari or the mission of the whole world, by 2030 or 2035 or 2040, maximum of the countries, they are planning to make a 60, 80 or 90 or 100% push for EVs on their road. Now, EVs need electrical energy for their running. Now, most of the time, what we are doing right now, or our concept is, we are daily commuting to our offices, bazaars, and everywhere, and there we are putting our EVs in the night for charging. Now, assume that the whole automobile industry has converted to EV, and everyone is at their home respectively, and
Hmm.
they have put their EV on charging. Now, this kind of surcharge, extra charge, which will be drawn from the grid, may be possible solution for a grid failure. Because grid either be of India or Germany or Denmark, it is not of that level so that it can charge the whole EVs at the same instant from 12 to 6 in the morning. So obviously there will be a crash. So we should be looking upon some other kind of energy solutions also, which scientists and researchers are going on, which is known as renewable energy solutions, extracting power from wind energy sources and PV solutions. Now, PV solutions, yesterday only I read an article from someone from Tesla that since all the vehicles will be there, so PV won't be able to charge everyone. Obviously, because PV is in the daytime and by the 6, it goes off maximum some places 7. So what the other solution? The other solution is wind energy conversion solution. Because
Hmm.
after wind, when we are extracting power from the wind, the maximum power is coming in the night time. And usually it is from 12 to 4 in the morning. So this is the best possible solution which we can go for an EV. Because in the night time, the EV demand will be there. And in the night time only, wind will be there. So we have to somehow cope up with these kind of sources.
These things have been perfectly synced by nature itself. Apparently, things
Yeah,
are lining up one way or the other.
yeah.
Great. Moving on to the next question, sir. We have many students working in student formula teams competing in SAE competitions. So we would go a bit technical here. In terms of design perspective, what are some of the key aspects that are to be considered while building an EV?
Yeah, SAE competitions and Formula Bharat competitions, different competitions are there in India, pan India and across India also. So many students are working upon that. In fact, students from our organization, our institute are also working upon these kind of competitive Formula Bharat schemes, and SAE is also a major part of our institute. Now, the first thing that any student which is working upon SAE or Formula Bharat kind of competitions, they should be knowing about some of the software basics. Like softwares, like we should be in the terms of ANSYS, CATIA, or they are somewhat heavy kind of software. They should be starting with SolidWorks. SolidWorks is somewhat comparatively easier kind of solution for a for a mechanical or electrical engineer to venture in EV. And obviously, they should be learning some of the skills of software like MATLAB and Motorsolve. So these are the software platforms that they should be working upon. They should be, after learning this kind of software, will be designing the chassis. The chassis is the main thing of the EV or any vehicle automobile industry. So chassis design is very much important. Next is the how to derive a powertrain from. It should be mid drive, it should be hub, or it should be what, it should be differential. So it should be very proper through check. And moreover, the dead weight of our vehicle should not be like that. Dead weight is very high, because dead weight itself is a kind of loss for a whole system. Moreover, the aerodynamics also plays a major role. It
Hmm.
should be perfect so that the vehicle streamline in the forward direction in a smooth manner. So all these things, apart from the safety and the reliability, the safety and reliability means, suppose someone is driving at a speed of 120 kilometer per hour, and suppose the powertrain fails and all the electrical systems fail or a tire bursts. So what should be done? So these kind of issues should also be taken up, and they are being taken up by the different students of our organization and the students which are working in this field. Basically, SAE and Formula Bharat are basically more insistent and persistent about the safety and regulation features. Because on roads, if you are driving such kind of vehicle at a high speed where the other vehicles are also driving at 115 or 122 kilometers per hour, any slightest kind of notch may result in loss of life and many more things. So this is what the students should consider in all those areas.
Great. So apparently, safety is something which is often overlooked at, but it is really crucial to be building a very safe and a very healthy e-mobility ecosystem.
Very right, very right. Safety is a kind of solution because see, technology has many solutions. So many are feasible, many are mathematically only not feasible. So out of these mathematically feasible solutions, we should be trying to achieve and work from those kind of solutions which are benefited for the humanity,
Correct.
right? So until unless it is giving a soothing touch to the person or a humanity, the technology won't work. It will be good, it will be awesome, it will be very much efficient, it will be very least cost effective. But the ultimate thing is who is going to take the pleasure out of that? So humans should be the center point for focus point for all these kind of technologies.
So ultimately, it all boils down to the utility for humans of any particular piece of technology.
Exactly, perfectly, perfectly. That's what humans for EV is. Right, exactly.
Well, you thank you for mentioning that. It had not crossed my mind, but humans of EV may have that connotation as well. Thank you. Okay, so moving on to the next question. Would you like to explain to the students who joined here the influence of theoretical and practical knowledge they may gather in the EV domain?
See, obviously, theoretical knowledge is a must for everyone, right? But theoretical knowledge itself doesn't do miracles. We have to blend it with the practical kind of things. We should be going in the practical world, either industry or on the road or any kind of field where those solution or the problems are coming from. So we should be working on those theoretical parts with that practical solutions. So, for example, that I like to tell you is suppose everyone studies electrical engineer, whosoever is in third year or final year must be in the speed control of a DC motor. So mathematically, if I'm speaking of a speed control of a DC motor, many tests or exams, he must have written the same answer. Field control is a method for speed control, and field control is a method for speed enhancing, means increasing the speed of speed motor or EV. So the thing is, what is the upper limit for this one? So can it be infinity? Mathematically, it is yes. You can go for it. But no, practically, it is all these aerodynamics, drag force, road, friction, dead weight of your body, your fuel, how much current it can give, what is the powertrain, what is the capability of energy storage, and what G you will be experiencing. Because at higher speeds, the G will also change. So all these things should be considered while we are going for the theoretical aspect. Theory always, as many people have said, won't ever do a miracle. Should be blended with the practical things, and until unless it is blended with practical things, it is of no use.
And also we run into obstacles only when we delve into the practical applications of things. Otherwise, theoretically, everything sounds very nice. I mean,
Very nice,
all
right?
sheep and no cattle kind of a scenario. Oh, sorry.
Exactly, exactly.
All hats and no cattle. Sorry, I may have heard all hats and no cattle is the phrase. So that would be something that just theoretical knowledge amount to. um, all right. So moving on to the next questions, what are your thoughts on because this is something very important and I mean, time down the line, we'll certainly come across this gigantic task of waste management. And so I just wanted to have your thoughts on waste management of the conventional vehicle, which we will certainly shortly face. And what would be some future measures for managing electric waste, and how can students contribute to this?
See, obviously, when a technology is going for a paradigm kind of shift, many changes are there in the technology, and many technologies are going to be obsolete. Now, these technology also means the kind of applications and the equipments and the softwares that were already being used in the previous kind of cases. In our case, it's an IC engine. So IC engine is going to going to be replaced by an EV electrical motor. Electrical motor. So electrical motor, if I'm talking of, the very first thing which will be getting obsolete is the battery. The second one will be the motor if it is a permanent kind of motor. The solution that we have worked upon is an induction kind of motor. It will never go off because only the windings will blow up, and you can do some kind of other kind of alterations, and the motor will go on running. Batteries, as you have already known, the batteries are a very costly kind of affair, and the materials that are used for these kind of batteries, they are also lithium and ion. So some at some part, lithium and ion are kind of solution, are a kind of materials which are which can be reused or they can be recycled also. So the recycling of these batteries and all these parts is also a major issue. And a major industry parallel to the EV industry should also be running. We should be running for the recycling part of all these things because it's we being humans have no right to pollute this environment, all this planet. We are getting the best from this, so we should also do the best for them. We should not put garbage, we should not throw our batteries or motors or dump our vehicles here and there so that it becomes a burden for our next generations to come upon, either be our generations or to be the flora fauna or the other kind of animals and their habitat. So it is our prime concern that we should be also working from the core point of view for the refurbishment, backfitting, and the recycling of these kind of products, even for the batteries, for the permanent magnets, and all these kind of things.
And sir, do you suggest this to be when you draw up a solution, when you draw up an idea, when you sketch it? So there are certain parameters that you already have in mind, that these are the parameters that I have to consider, and I'll have to make sure that my idea scores well on these particular in these criteria. So waste management. Do you think waste management of a particular piece of technology or something that is revolutionary coming about or is being proposed to come about, should waste management, effective waste management of that technology also be a very important factor that should be taken into account when developing it and then further commercializing it?
Yeah, waste management is a kind of thing that should go hand in hand with the growing technology because the things or the equipments or the apparatus that we are making obsolete from an automobile industry, they should be somehow going to be used in some or the other part. For example, if I tell you, we are having tires. We are having tires which are normally filled with air, and we are having some kind of solutions for energy storage. Now, the energy storage, some kind of solutions or energy generation, one of those methods is piezoelectric method. So, piezoelectric method is a kind of solution where the pressures are there. Depending upon that, the energy is being produced.
Mm.
Some separate ideology is that when the tires are filled with some kind of air pressure, they run smooth. If higher tire pressure, they may burst. If at low tire pressure, more less efficiency is there. So mixing these two worst parts, a worn out tire and a piezoelectric worn material, there are some kind of technologies, and we are working on this field also. That using piezoelectric materials and worn out tires, we are trying to generate power. So it should be something like that, getting best from the waste. It is not only picking up new things and making your house. It is also like that when we are making food in our homes, some leftovers are there for the night. We should be consuming it in the morning. We should not be throwing it away like that. So likewise, it is for the EV industry also. And this backfitting or the retrofitting kind of solutions should be there because we cannot directly discard any IC engine, right? Even after 15 years, what the norms of India say that it should be discarded, they should be reused with the help of an IC engine. So the whole machine, if it is going to be dumb, it is a loss to the nation. Either to the person, it a loss to the nation, it is obviously there. So we should be fitting some hub kind of motors in that so that the whole vehicle has lives increases and the lifespan increases, economy is somewhere it is benefited. So economy is one thing, humankind will be benefited in the later end. So waste management is a thing which should always go hand in hand with the growing technologies, either be of EV or either be a cloth industry or any kind of industry, either be a softwares or any other field. You're very right.
Correct. I mean, if we just go blindly discarding everything, so these being exhaustible resources, ultimately we'll be left with nothing to build. We'll just be, as you said, we'll just be writing something in theory, but have nothing to build anything out of. So practicality goes out of the window then. Um, okay. What would a trans? This is the last question of this list. Okay. What would a transition from ICE vehicles to electric vehicles look like in the educational sector in terms of changes in curriculum?
Yeah, right. This thing is very much important in the Indian perspective, because in India there is certainly a different kind of expertise level of the industry people, and it is totally different what has been taught in the industries and universities and institutes. So the academia industry gap that we are talking of, if the name typically for this one is academia industry gap, if it is there biggest in the whole world, then it is in India. Because in education, we are taught something else. In industry, we need something else. Even the top software giants, TCS, Accenture, IBM, Google, Microsoft, they hire students and they train them for 4 months, 6 months, 8 months, like that. And after that, they make them sit on a platform. The same goes for Jindal Steel also. The same goes for Tata Steel, Tata Motors also. So EV is an industry which is right now growing. It is in R&D stage. Many things are in R&D stage. And when the curriculum starts adopting these kind of R&D stages at their curriculum level, the students will be benefited and this bridge will be gapped. So for this, what we can be doing, or many industries are basically now going for that, they have started specialized courses. For example, mechanical engineering, specialization in hybrid electric vehicle. Some certification courses from governments are there, which are giving software hybrid vehicle certifications, electric vehicle, BLDC topology. So these kind of certification programs are also there, initiated by the central government and different state governments. Apart from that, skill development societies and skill development institutes are also developing, and they should be developed at par with the industry. The ultimate aim is the industry and academia, this bridge should be filled up. And for filling up this, center of excellence, for example, is one of the best thing that we should be having in all the institutes, where the industry people are coming with their ideas. They are giving live projects to the students. The students are working with this software or hardware kind of companies, like EV is a company, industry. EV industry company should come in the center of excellences. They should interact with the people, with the faculty members, upgradation of the knowledge of the faculty members, students, and the future employees of these companies will be coming from that. So if a company like XYZ is coming to a college ABC and is telling that we have a problem of some problem statements are there and they are floating it, someone is working on this, we will be giving them 10,000, 15,000 per month stipend. So the students 10, 15,000 is very good amount. They will be working upon that and this can be converted in projects. After that, what the industry will be getting, these students either be in second year or third year, they'll be working upon their problems since 2 years. So no need of any training, no need of dead time, 6 months to 8 months of training. Directly after BTech, they can be absorbed. So various certification programs, specialized courses, and skill development societies and center of excellences should come up and to bridge this gap and for this exploration of EV industry.
And another thing, I mean, please correct me if this is not something that can be looked in. I mean, this is not a direction in which we can look at. But on the note of these companies that you mentioned, them having the advantage of picking students who have already worked on this technology. So what I think is, when a student is picked up and the company trains it on a proprietary thing, maybe a one or two things, and then there are not many challenges that a student may come across when going through a set training program, because multiple students are going through the same thing, and it is more like, it is quite a robotic thing in a manner. But when the student is working on something very live and something which has got challenges in real time, such as building a project in, let's say, e-mobility, so those challenges, the students are bound to answer those challenges, find answers to those problems on their own, and be more ingenious with their approach, right? So the companies will have younger yet more experienced professionals to hire in the pool, instead of
Exactly.
having just a person who's got the benchmark education and then training them up beyond that.
Perfectly said, Anup. Perfectly said. Very right.
So it was indeed enlightening to listen to you. I am for sure gratified to have you here, and I'm certain that our audience feels the same. Thank you for your time, and thank you for your time to the audience as well for tuning in. Let's meet again in the next webinar of this series at Humans of EV. Till then, keep yourself updated with the latest trends in e-mobility with us. You can follow us on LinkedIn, Instagram, Facebook, and Twitter, and interact directly with us on LinkedIn and Facebook. See you soon again.
Thank you, Anup. Thank you, Humans for EV. Thanks a lot.
Thank you
Have
so
a
much.
nice day. Bye.
Thanks.